students, welcome in ASO Technical Campus. Today, myself Professor UJT explaining the power in power electronics. The topic is UJT. Now, give the heading. New topic is UJT. Now, what is the long form of UJT? UJT is nothing but Unijunction Transistor. Unijunction Transistor. Now, first of all, I will draw the diagram for unijunction transistor. Say that it is a construction diagram. Base 2, here base 1, these two are ohmic contact, then this is called as a PN junction. This is a emitter terminal, and also this this rod is called as a aluminium rod. And this is called as a silicon slab. This is the construction diagram of UJT. Construction of UJT. Now see here, in this construction diagram, first of all, UJT means unijunction transistor. Why it is called as a unijunction transistor? Because only one junction is present, called as a PN junction, hence called as a unijunction. Uni means one and junction is junction. Only one junction is present, hence called as a unijunction. Then this UJT has three terminals: emitter terminal, base 2 terminal, and base 1 terminal. This base 2 terminal is closer to emitter terminal, hence this base 2 is most positive than the base 1. Or we can say that it is at higher potential than the base 1. Base 2 is at higher potential than the base 1. Now here two bases are present, that is base 1 and base 2. Hence it is also called as a double base transistor. This is the construction diagram. Here this rod is present of aluminium rod and this slab is of silicon slab. Hence this here one diode is formed or one junction is formed called as a PN junction, and means we can say that PN type of diode is present there. Now this is the construction diagram. Now I will draw the symbol for UJT. This is the emitter terminal. Having two base 2 and base 1, and this terminal is called as a emitter terminal. This is the symbol having three terminals: emitter, base 1 and base 2. Now also I will draw the equivalent diagram for this UJT. Here I will draw the equivalent diagram. Now see, this is the PN junction and emitter terminal is brought out for this PN junction. Hence here this is the emitter terminal. After that PN junction diode is there. Emitter, then PN junction is there. This is a P type, this is the N type. Call it as a diode. PN junction diode is there. After that, base 1 and base 2 resistors are there. Here, first one resistor, second one resistor. Here I will told you that base 2 is closer to emitter terminal, hence it is at more potential than base 1. means we can say that this base 1 terminal is connected to the positive potential and this base 2 is connected at positive potential, means at higher potential. Base 1 connected to the ground, means it is at lower potential. Now this resistor is at base 1 side, called it as a RB1. This resistor is at base 2 side, called it as a RB2. This is the equivalent diagram for the UJT. Now from this equivalent diagram, we will calculate the intrinsic standoff ratio. Now what is the intrinsic standoff ratio? This intrinsic standoff ratio is nothing but the ratio of, I will write here, intrinsic standoff ratio is nothing but the ratio of ground side resistance, that is RB1 upon total resistance, that is RB1 plus RB2. This is the intrinsic standoff ratio, and equation for this is RB1 upon RB2 plus RB1, that is total resistance. This total resistance RB1 plus RB2, it is also denoted by RBB. This is the equation for intrinsic standoff ratio. Now, what is the operation of UJT? The operation of UJT, I will explain the characteristics of UJT so that you can easily get its operation. Now, I will draw here characteristics. Here, I will draw the characteristics of UJT. Now, observe here. This is a peak voltage VP. This is the emitter voltage. Then this is the current axis, that is emitter current. Here, from this line, cutoff region, here from this point up to this point, saturation region. After this, negative resistance region, and here saturation region. Now, these are the high characteristics of UJT. Named figure. VI characteristics of UJT. Now, see here working principle also clear and VI characteristics also clear. This VI characteristics is the graph of voltage versus current. On y-axis there is a voltage and on x-axis there is a current. Hence it is called as a VI characteristics. Now this VI characteristics is divided into three regions. First is cutoff region. Here first is cutoff region, second is negative resistance region, and third is saturation region. Now see one by one. First is cutoff region. In this cutoff region, your applied emitter voltage is less than peak voltage. This is a peak voltage, means highest voltage, and when your applied voltage is less than this peak voltage, in this case your UJT is in off condition. Hence this is called as a cutoff region. Means we can say that in other words, in cutoff region your UJT is in off condition. Now second region is there, that is negative resistance region. In this negative resistance region, when your applied voltage, that is emitter voltage, reach to peak voltage, after that by increasing your emitter current, voltage start decreasing. This region is called as a negative resistance region. And after that, third one region is saturation region. Means in this second region, your UJT goes in on condition. Now, in saturation region, what happens? When you are in negative resistance region, by increasing current, your voltage start decreasing up to certain limit. After this certain limit, by increasing current, again your voltage start increasing, means your UJT goes in saturation region. And when that point, this is a point at which by increasing current, voltage also start increasing, this point is called as a valley point. And voltage present at this valley point is called as a valley voltage, and current present at this valley point called as a valley current. These are the VI characteristics. From this, it is clear that when your applied voltage, from this point, it is clear that your applied voltage is nothing but your emitter voltage is less than peak voltage. At that time, your UJT is in off condition. Second, when your applied voltage is greater than peak voltage or equal to peak voltage, at that time UJT goes in on condition. This is nothing but your working principle, which is explained with the help of characteristics. Because without characteristics, it is difficult to understand the student. Now, see here. Again, I will say, repeat this statement, that is emitter voltage is less than peak voltage. In this case, your UJT is in off condition, means your UJT present in cutoff region. Now, when your applied voltage is greater than peak voltage means at this point, your UJT goes in on condition and it get turned on. Now, see here. This is the construction diagram. After that, I will draw this symbol, and for explaining its working principle, this working principle is explained with the help of VI characteristics. That is Unijunction Transistor. Now, this is the point, that is UJT. Now see application. Why we learn this UJT? Because this UJT has the important application, and out of that, first important application is it is used as a triggering device for SCR and triad. Because for SCR and triad, we need the gate pulse, and to provide the gate pulse with proper voltage and current, we need the UJT circuit. When we provide directly gate pulse, it may damage your SCR, and to avoid this, separate circuit is designed for triggering the SCR, that is the UJT. It is used for triggering SCR as well as triad. And now second application in UJT is the relaxation oscillator. We know oscillator is nothing but the wave generator. That is without input it will generate the waves. In this case also, Unijunction transistor is used. Hence, it is the most important device used for triggering the SCR as well as triad, and also for it is used in relaxation oscillator. Now, in next lecture, we learn the PUT, that is Programmable Unijunction Transistor. I will told till now it is and there in PUT flexibility get increases. So in next lecture we cover the PUT, that is programmable unijunction transistor. Thank you guys.